Alright, hi everybody. Today we're going to talk about metamorphic rock identification or classification. So we're going to do a lab in the next day or two where we're going to give you guys some rock samples, and you're going to have to try to classify them and put them into the appropriate grouping. Alright, so there's really a couple things we got to look at when we're doing metamorphic rock identification. The two things we're going to look at are composition, so the material that it's made out of. Big one's texture, though. So what's the texture of the rock? So metamorphic rocks are commonly divided into two groups, the two groups being foliated and non-foliated. So that'll be kind of your first thing you're going to look at when you're trying to separate these two things. Let's look at non-foliated first. Non-foliated rocks are mosaics of equal-dimensional minerals. So they don't contain elongated minerals. You're not going to be able to kind of see layers, if you will. It's going to kind of just look like one big mass. Larger grain sizes that are resulting from the recrystallization. So when that rock gets put under all that heat and pressure, those mineral crystals will recrystallize, sometimes to form larger grain ones. It can be from one mineral type, or it can have very small crystals from multiple types. So that's what we're going to look at. Non-foliated metamorphic rocks, it's real helpful to kind of base it on composition if you can figure that out. But so your limestones, calcium carbonate, are going to result in marble. Okay, quartz, okay, is going to be forming quartzite, and then anthracite is coal that has been exposed to extreme heat and pressure. So we call it hard coal, or what we officially call anthracite. Okay, so here's some examples. Here's marble. You can see the limestone over on the side here which we looked at, is a sedimentary rock, right? It's formed in deep marine environments, and then lots of heat and pressure change it into marble. Okay, marble is going to have kind of a sugar cube kind of a look to it. Okay, quartzite. Let me move this guy out of the way here. Quartzite, okay, is very hard because quartz is a very hard mineral. So sandstone, so you start with sand, that's just sediment, that gets turned into sandstone, which is a sedimentary rock. And if that sandstone gets, again, metamorphized or gets put through a lot of heat pressure, is going to turn into quartzite. Okay, foliated. Okay, so what does that mean? So that means minerals are going to be parallel or layered to one another. So you can see over here on the side, you may have a piece of granite, for example, or one of those igneous rocks that has kind of just nice crystals organized. You can see here, and then you get a lot of pressure and heat, and then those mineral crystals start to line up and form a foliated. So you can see kind of the bands here going up and down. That's a foliated rock. So you go from this kind of a look to that look. Alright, so increasing metamorphic grade. What that means is you may have a sedimentary rock like slate, and as you increase the amount of heat and pressure that it's exposed to, it's going to change from one type of rock to another type of rock. Okay, or one type of metamorphic rock to another type of metamorphic rock. So in that shown here in this picture, you're going from slate to phyllite to schist to gneiss. Okay, and as you go across, these crystals are getting a little bit bigger as you go across. Okay, so from slate to phyllite to schist to gneiss. So we'll look at each of these. So again, the idea is the more heat and pressure you expose it to, it's making those crystals, or the crystals that are present in that original sedimentary rock, to recrystallize into a new rock. Okay, so here's your slate. Okay, or now shale is what the metamorphic rock, or the sedimentary rock is, excuse me, and that gets turned into slate. And here's your slate roof, slate pool table is what it's used. Now if you expose that to more heat and pressure, that slate then turns into phyllite. So you can see the phyllite over on the side here. It's a little shiny, right? You can tell it's been exposed to a little bit of heat and pressure. Now if you continue to take that phyllite and you add more heat and more pressure, it then turns into what we call schist. Okay, I know, funny name, weird name, but it is what it is. It's called schist. So it kind of has this scaly look to it. So again, those little crystals are recrystallizing, and the grain size is getting a little bit bigger. And then lastly, you go to gneiss. Okay, so you take that schist and it turns into gneiss. And you can see kind of the foliation as you go here. Now this provides lots of opportunities for bad puns, so I've given you some here to enjoy. Nice shirt. Get it? Schist happens, metamorphically speaking. This is some nice schist. Hey, it's geology class. These are geological terms. Alright, you guys, if you guys have questions, rewatch the film, catch me in class, shoot me an email.